For a table of values for y equals log 2 of x, what are ones that you know? Because remember, a log, this log 2 of x is asking you 2 to what power is equal to x. So you can change it to exponential form or even just start reading it that way without having to write it down. So what are some of the powers that you know? Well, if I plug in 2 for x, it's got to be 1. Right? Because 2 to the power 1 is 2. What are our other powers of 2 that we know? We know 4, right? So if I plug in 4 for x, then y would have to be 2. All log graphs have 1, 0. That makes sense because if I plug in 1 for x, 2 to the power 0 is equal to 1. So we could make a longer table of values if we wanted to. And we could sketch the graph of log base 2 of x. Again, for sketching the graph, you need to know that it has 1, 0 and 2, 1. From our table of values, you could also include 4, 2. And there would be an asymptote right here at x equals 0. So just like all of our other transformation questions, if we're going to graph log base 2 of 2x minus 1, we have to be able to recognize what's the parent function. What's the graph that we can graph already? And what did we do in part already up here? We graphed y equals log base 2 of x. So if that's my parent graph, I have to decipher from here what are the transformations and what was part of my original graph. So looking here, if this is my original graph, log base 2 of x, then this log with this 2 and this x show me that that's my parent graph. What's highlighted there will not affect my graph. Just what's not highlighted will be the transformations. So the first thing we run into is this 2 inside of my log. That 2 is going to be a horizontal compression by a half. Same as it's always been. When a number is inside your function, it's going to affect it horizontally. And the 2 would mean multiply your x values by a half. So what we're going to do is we're going to take our points. We have 0, 1 and 2, 1. Those are our points on our original graph. And as we go from left to right, the 2 is the first thing we run into. And that's going to multiply our x values by a half. So we'd still have 0, 1. And now you'd have 1, 1. Yes, did I? Thank you. Boy, I had like 5 hands up. That's awesome. 1, 0. Now is 1/2, 0. And then the minus 1, will that move it left or right or up or down? Is it inside the function or is it outside of the function? It is outside of the function. If they wanted it inside the function, they would have to add a set of brackets there to make sure that you knew that that minus 1 was inside of the function. So that minus 1...
Hi there.
Hello?
I'm sorry for interrupting, Mr. JR. Did you have just the maximum positive?
And that will move this to 1/2, -1 and 1, 0. Is our asymptote going to change at all? And our asymptote is a vertical asymptote. The only way a vertical asymptote is going to change is if you shift it left or right. And we don't have any shifts left or right here. So throughout all of this, we will still have x equals 0 as our asymptote. And that's going to be enough to graph our new function. We can put our asymptote in at x equals 0. And from there, we've got our points. We're going to have 1, 0, and 1/2, -1. Our graph still approaches our asymptote, still has the same general shape as what we started with. And there is the graph of y equals log base 2 of 2x minus 1. It said in the question to graph them on the same grid. I find it's often easier to graph them separately. So we did our original graph there, and now we've got our new one. What's happened to it? It has been compressed horizontally and then shifted down 1. And then for part C, it says identify the intercepts, the equation of the asymptote of the graph, and the domain and range. Can you see that the domain and range are going to be the same as what they were before? X is greater than or equal to 0 for the domain, and the range is everything. We don't have any y-intercepts, and our x-intercept is 1, 0. And our asymptote is at x equals 0. Now, if you turn the page over to page 404 and 405, you have some space in the columns there. Or did you leave space at the top of page 403? Maybe on 405 you have some space in the column there. I'm going to do two more graphing examples. You also probably have space, if you don't want to do it there, you have some space on page 387. Y equals log base 4, or 4, log base 3 of x plus 1 minus 5. And I'm going to give you guys a head start to try this one. So first of all, we have to recognize that the parent graph is a log base 3 graph, which would have 1, 0 and 3, 1, and this shape with an asymptote at x equals 0. So we can take those points, 1, 0, 3, 1, and our asymptote x equals 0, and apply the transformations. Going from left to right, again, you may want to highlight the log 3 and the x just so that you don't think that 3 is part of a transformation. The first number we run into is a 4, and the only stretches and compressions will be that 4. You're going to multiply your y by 4, and your x doesn't get multiplied by anything. So that will keep this at 1, 0, and change that to 3, 4. The next thing we run into is our transformations left, right, up, and down. The 1 will move it left 1, and the 5 will move it down 5. So left 1 will go to 0, down 5 to -5. Left 1 will go to 2, down 5 to -1. Will our asymptote change? Yes, because we're moving left 1, it will go to x equals -1. Yeah.
Still follow DAB C, so we did D first.
That's only for sine and cos. So we're only going to do the DAB C if we have a sine or cos graph. Other than that, now we're going back to transformations where we work from left to right. So here we're going to have x equals -1 as our asymptote. The points that we have are 0, -5, and 2, -1. And so there's our graph, has the same shape as the graph we had before, but we've done some transformations to stretch it vertically, move it left, and move it down. Another example for you to try. Y equals 2 natural log of 1/2 x plus 2 minus 3. So we have to factor this one first. Factor out the 1/2. Now when I factor out a fraction, one of the things that I find useful to sort of figure it out is I take it out and then I ask myself, well, I know that 1/2 times whatever this number is here has to equal 2. And so that sometimes can help me think a little bit easier that this number has to be 4. Because taking a half out of 2 is sometimes a little bit harder to conceptualize. But it's basically asking how many halves would make up 2. And back when they used to make the pop bottles 500 mils instead of 600 or 710 or whatever they make the bigger plastic bottles now, it was an easy question because if you had a 500 mil bottle, how many of those would you need, because that's a half a liter, to fill up a 2-liter bottle? And that visualization is quite easy to see that you would need 4 of them. And that's basically what's happening when you're factoring a half out of 2. Anyways, so we still have -3 here. And so our parent graph is the natural log of x, which has the same shape as all of our other log graphs. It has 1, 0, and since the base is e, it has e, 1, and an asymptote at x equals 0. So we're going to take e, 1, 1, 0, and our asymptote x equals 0. And apply our transformations. Now going from left to right, we have a vertical stretch and a horizontal stretch. So I know that I'm going to have to multiply y by 2. I'm also going to have to multiply x by 2. So 2 times e would be 2e, and 1 times 2 would be 2. And then the next thing I see is the 4 and the 3. The 4 is going to be 4 to the left, and the -3 is going to be 3 down. So 4 to the left, you would write 2e minus 4, comma, -1. And 4 to the left would give us -2, -3. And the only thing that's going to affect our asymptote is when we move it 4 to the left. So it'll be now at x equals -4. So when I'm going to start here, I'm going to start with my asymptote at x equals -4. I'm going to label our 2 points. I'm going to start with -2, -3, because that's the easier one to label. And when you're labeling 2e minus 4, you can use an estimate. E is 2.7. So 2 times 2.7 would give us 5.4. Minus 4 would give us 1.4. So I'm going to label it about at 1.4, comma, -1 as an estimate. And I'm still going to label it as the exact value, 2e minus 4, comma, -1. The shape is still the same shape as before, just going through those 2 points. So graphing ones from your homework that you can practice are questions 8 through 11.